guys, Teacher Natalie here. We are going to be talking about graphs today. Hopefully most of this is review for you. If not, this will be a great learning tool so that you can be ready to go when we come back to school. So let's get started. Today we are going to be talking about graphs. What is a graph? A graph is a way to visually represent data. It is made up of two axes. There are many different types of graphs. There are line graphs, bar graphs, and scatter plots. Talk about a line graph. A line graph is a great tool to track change over a long amount of time. It is also good at showing smaller changes. And they are most common to compare change over the same period of time in more than one group. A bar graph presents categorical data in a rectangle. The height or length of the rectangles represent the values, and you can see that in the bar graph below. They can be plotted vertically, which remember is up and down, or horizontally, which is like the horizon, flat. And they are best used to present categorical data. So that means different categories of data. So like months, breeds of dogs, students at schools, and they're used to show large changes. They're not good to show small changes like a line graph would be. A scatter plot graph is when points are plotted onto coordinates. So that is the graph below. And they work best when comparing large amounts of data when it does not have regards to time. So below you'll see they're looking at temperature and sales and how those two things are correlated. So you're plotting a bunch of different data points onto a graph. And this is a good way to show the relationship between two variables. Now look at a couple examples and see which graph you guys think would be the most appropriate. If you wanted to track how quickly two different plants are growing over time, what graph do you think would be appropriate to use? If you said a line graph, you are correct. A scatter plot also wouldn't be a bad idea if you were comparing a lot of plants. But we would not want to use a bar graph because plants don't grow that quickly, so it wouldn't show that much change. So because there is small change over time, we would want to use a line graph, and it's also nice that it can show the growth of more than one plant at a time. What if you wanted to show how many people owned a blue car, a green car, and a black car? Which graph do you think would be the most appropriate? If you said bar graph, you would be correct. A bar graph would be best because it shows different categories. So the colors would be the different categories. And it also shows larger differences. So in a car, we would only be using whole numbers. Obviously, you can't own half of a car. So we would only look at whole numbers, which would be a larger difference. It would be easier to see on a bar graph. And finally, if you wanted to show the relationship between the height and weight of a population, what graph would you use? If you said scatter plot, you would be correct. Remember, we are going to be looking at a whole population. That's a huge number of people, so that would present a lot of data. Also, not related to time, so a scatter plot would be appropriate. So graphs. All graphs should have these parts if they are a proper graph and a good graph. They all need to have a title. They all need to have axes. They all have increments, labels, and a scale. The title, this should summarize the information on the graph. It is placed above or below the graph, and the proper form of a title would be the y-axis variable versus the x-axis variable. All right, axes. So every graph will have an x and y axes. The x-axis will be the horizontal line. Remember, horizontal will be this way, and it will be the independent variables. Independent variables are what is changed or controlled. So time would be an example of an independent variable that is always changing, and we are controlling the time that is passing. And then our y-axis is always going to be the vertical line. That is the up and down line, vertical. And this is a dependent variable. That is what we are testing. So there are lots of examples for that. If you were looking at acceleration of a car over time, you would have time in your x-axis and acceleration in your y-axis, right? We're testing the acceleration, we're not testing time. Increments. Increments is the space between the value of the scale. You choose your intervals based on the range of values in your data set. So if you are going from 1 to 1,000,000, we would not want to have increments of 1. That would be an extremely large scale. A better increment would be maybe thousands. Labels. It's important that we label things so that your data has meaning. Otherwise, there's just a bunch of dots on a page. We don't know what it means. So you want to identify which variable the x and y axis represents, and it should include units for the scale, and the title is also considered a label. We are going to talk about plotting points on a graph. So we've got our title already. We're going to use year versus visitors to the park. So what will we be labeling our x-axes? Yes, it is going to be year. And that means that our y-axis will be visitors to the park. And remember, we're using by the thousand. You can see that in the chart. Next, we're going to put in the labels of our x-axes. So those are going to be the years. And then we are going to use just some increments, whole numbers for the y-axes. All right, so now let's get to plotting points. So I'm going to look over here. I have 2015. This is on my x-axis. So I'm going to go to 2015, and then I will go up to my y-axis, and that will be 1. I'll put my point. Then moving over to 2016, I will go up to 4 and put my point. Then 2017 is only 2, so I'll put my mark at 2. 2018, if you look at the chart, it's going to 3, so 1, 2, 3. And 2019, we're going to 1, 2. And finally, in 2020, there are 4,000 visitors, so we will move our mark 1, 2, 3, and 4. So now we have plotted the points for our graph. We have a graph with some points, and I want to put them into the chart. So I'm going to look at year. Where do we see year? Down here. So we will put in 2015, 16, 17, 18, 19, and 20 into our chart. Now we're going to fill out the visitors by the thousands. So for 2015, we look here, we go up, and we see it will be 2. For 2016, we look, go up, it is 1. 2017, 1, 2, 3. 2018, 1, 2. 2019, 1, 2, 3. And 2020, 1, it's not all the way to the 2 or the 1. It looks like it's about at 1.5. So that is what we will get for 2020. Congratulations, you made it all the way to the end. Great job. If there are any questions that you have, you can log in on Friday and we can chat. There are some example problems for you to do that are attached, and hopefully this wasn't too boring. Thanks, guys.